conservation of momentum. So let's look at the example on your collision lab that we did today. Let's kind of review that a little bit. We have ball 1, we have ball 2, and we set it up with the following conditions. If we look at the initial momentum of ball 1 has a mass of 3 and a velocity of 2. So on our mass velocity graph, we're going to make a block that is 3 kilograms wide, and we're going to make it 2 meters per second tall. Ball 2 has a mass of 1, and it's not moving, so we're going to just say it has a 0 meter per second velocity and put an X on it. So it doesn't have a block. For the final conditions, ball 1 still has a mass of 3, and ball 2 still has a mass of 1. Ball 1 is now moving to the right with a velocity of 1 meter per second. So we're going to make our block 3 kilograms wide and 1 meter per second tall. Ball 2 still has a mass of 1 kilogram, so it's going to be 1 block wide, but it's now moving with a velocity of 3 meters per second. So we're going to make that block 3 meters per second tall. So let's look at this momentum. The momentum of ball 1 is 3 kilograms times 2 meters per second, so the size of our block, which gives us a positive 6 kilogram meters per second. Ball 2 is not moving, so it has a 0 momentum. If we look at the total momentum before the collision is going to be 6 kilogram meters per second. So ball 1 has a momentum of 6, and ball 2 has a momentum of 0. So the total will be positive 6. If we look over here in the final, the ball 1 is moving now with a velocity of 1 meter per second. So 3 times 1 will give us positive 3 kilogram meters per second. Ball 2 has a mass of 1 and a velocity of 3. So it also has a momentum of 3 kilogram meters per second. So if we look at this, the total momentum on the final is also 6 kilogram meters per second. This is what the conservation of momentum is. The total momentum before a collision is equal to the total momentum after a collision. Now, this is assuming perfect conditions with no friction, no loss of energy anywhere. So this is a pretty rare thing, but we'll get into that a little bit later. So the law of conservation of momentum, in the absence of an external force like gravity or friction, the total momentum before the collision is equal to the total momentum after the collision. So this is the example on your worksheet. Ball 1 has a mass of 4 kilograms and is traveling to the right with a velocity of 3 meters per second. Ball 2 has a mass of 2 kilograms and sits at rest. So let's look at these initial conditions. Ball 1 has a mass of 4 and it has a velocity of 3. So we're going to go over 4 and up 3. Ball 2 has a mass of 2 kilograms and it is sitting at rest. So we're going to go over 2 and up 0. After the collision, ball 1 continues on to the right with a velocity of 1 meter per second. So it still has a mass of 4, but now it goes up 1 meter per second. Now the question is, what is the final velocity of ball 2? It still has a mass of 2 kilograms, but we are not given a velocity. So we have to figure that out. So let's go back to our idea of momentum. If ball 1 has a mass of 4 kilograms and a velocity of 3 meters per second, it's going to have 12 kilogram meters per second as its momentum. Ball 2 is not moving, so it has 0 as its momentum. So if we look at the total momentum before the collision, we have positive 12 kilogram meters per second. If we look at our final conditions, ball 1 has a mass of 4 and a velocity of 1. So it has a momentum of 4 kilogram meters per second. Now, conservation of momentum just told us that if we have 12 kilogram meters per second at the beginning, we should have 12 kilogram meters per second after. So to figure out what the velocity of ball 2 is, we have to look at our total momentum and how much of that momentum is already taken up by ball 1. So we need a total of 12, but ball 1 has 4. So that must mean that ball 2 has a momentum of 8 kilogram meters per second. So the 4 from ball 1 and the 8 from ball 2 would give us 12. So if ball 2 has a mass of 2, and we need 8 little blocks, right? We need 8 momentums. We're going to need to go up 4 meters per second. So 2 kilograms times 4 meters per second gives us our 8 kilogram meters per second. So using that conservation of momentum, we can start to solve some problems with these collisions.